Welcome to Homework Lib.
We have two samples of pure water at different temperatures, one at 282 and the other one at 339 Kelvin, and each of them are going to have different volumes. So remember that the heat that is going to be given by any of them is going to be equal to mass times the heat capacity times delta T. And what we're going to get is that the heat from the hot with a minus is going to be equal to the change of heat, or the heat that is going to be transferred from the cold water. Okay, so for each of them, what we know is that mass is equal to density times volume, and the value for density is equal to 1 gram per milliliter. So essentially, the volume that we're going to have is going to be the value of grams that we're going to get. So in the first case, we're going to get the mass of the hot water, that is going to be 50 grams. So mass of hot water is going to be equal to 50 grams. The initial temperature for the hot water is going to be equal to 339 Kelvin. The mass for the cold water is going to be equal to 30 grams. And the initial temperature for the cold water is going to be equal to 282 Kelvin. So what we're going to get is mass of hot times heat capacity times delta T is going to be equal to mass of cold times heat capacity times delta T for each of them. We can simplify this a little bit more. Notice that the heat capacities are already going to cancel out. So on the left-hand side, we're going to have minus m hot times final temperature, that is going to be in common, minus initial temperature of the cold one, of the hot one. And this is going to be equal to the mass of the cold water times final temperature minus initial temperature of the cold water. On the left-hand side, what we're going to get is initial temperature of the hot times mass of hot. And we're going to add any factor that doesn't contain the final temperature on the left-hand side. So from the right, we're going to take mass of cold times initial temperature, that is with a minus, so it passes to the other side with a plus. So plus initial of the cold times mass of cold, and this is going to be equal to mass of cold times final temperature plus mass of hot times final temperature. We can factorize the final temperature on those in this case, so this is going to be mass of cold plus mass of hot. So solving for final temperature, what we're going to get is initial temperature of the hot one times mass of the hot one plus initial temperature of the cold one times mass of the cold one divided by the sum of both of the masses. Notice that this equation, what it is telling us is that the final temperature is going to be equal to essentially a ponderated average of both of them, because this is going to be initial temperature of the hot times this factor, that is mass hot, divided by the sum of the masses for both of them, plus the initial temperature of the cold one times the factor of mass of cold divided by the sum of each of them. You can think about these quantities as percentages or as fractions, as you can see in chemistry, but regardless, the results are going to be the same. So the total mass in this case is going to be equal to 80 grams, and the initial ones are going to be the ones from the problem. So this is going to be initial temperature of the hot one, that was 339 Kelvin, multiplied by mass of hot, that was 50 grams, divided by the total mass, that was 80 grams, plus the initial temperature of the cold one, that was 282, multiplied by 30 grams of cold water divided by 80 grams in total. So the final temperature is 317.625 Kelvin, which in our answers is closer to 318, because we can round this up to three significant figures, so 318 Kelvin, which is the first answer over here. So with that, it would be all. Thank you very much and have a good one.